My name is Scott Hodgson. I am a technical marketing engineer, technical leader, which is a very long title. I've been with Cisco for about 22 years now. I've worked on the Cat 6K in the past. I've been doing software-defined access for the last 6.5 years or so. I'm based in Raleigh, North Carolina. And today I want to talk to you about shared services options with the new SD-Access extranet capability that we're introducing within the actually next version, or I'd say current version. It's kind of out intermediately right now of software-defined access that we've called GROOT internally. You might have heard of that, or its numerical number is 2.3.4. So the first thing I want to start off here is kind of why did we introduce this, right? So, um, of course, this is when things don't work. All right, sorry. So why did we introduce this? So if you look traditionally at an SD-Access architecture, you have your border nodes, your control plane nodes, which you can see as the BNCP here. This is the gateway to the outside world. The control plane node is what runs Lisp. Lisp is kind of the forwarding brains of the SD-Access site. You've got your edge nodes. And I've shown two different colored endpoints up there, one in a green VN, for example, one in a red VN. And if the green wants to talk to the red in a traditional architecture, usually our best practice is to go to some device, a peer device. I show a router here, but it could be a switch, it could be a firewall. And if I want to go from one VN to another, because a VN is just a VRF, then I have to do some kind of route leaking, and this is a manual operation. So this is why we usually recommend it to be outside the fabric. We're trying to do as much orchestration and automation as we can within the fabric, so all the edge nodes and control plane nodes and border nodes and et cetera. And of course, as we know, if you're doing anything manually like this, then there's more opportunity to perhaps get it wrong. Also, you have to take scale into consideration. If I start route leaking now, I could have TCAM blow up potentially. I have to now look at purchasing a device to be this peer device, et cetera. And so as you get into some of these architectures with lots of sites, if I'm looking at now to do this, even if it's just a shared service, if the red, the red clients or whatever are supplying some kind of service that the green clients also want to share, that gets into potentially a lot more money as well, because now I have to provide these peer devices. So what we want to do is we want to try to simplify this, right? Where there's two main use cases that we see for this. And one of them is using the GRT, or the global routing table, as what we call a provider. So as you look at SD-Access Extranet, there's a couple of new terms that we'll start throwing out there. One is provider and one is subscriber. So if you've been following SD-Access for a while, you might know that about a year, 9 months ago or so, we introduced something called publisher subscriber architecture, or pub-sub architecture. And what this does is this allows us to have a little bit of a different relationship between the control planes and the border nodes, where the control planes are effectively publishing, as the name implies, information to the border nodes. And this allows us now to implement something like this SD-Access extranet function. So here, for example, you can see I might be accessing, DNS, DHCP, all these kind of standard shared services, whether it's locally or perhaps, across the WAN in a data center. And I can now take specific virtual networks. And remember, a virtual network is a DNA Center construct. So in DNA Center, I call it a virtual network. In iOS, we call it a VRF. And in Lisp, we call it an IID, or an instance ID. Whenever you see these things mentioned, they're all exactly the same thing. So a VN builds a VRF and maps to an IID in Lisp. And in Lisp, Lisp is just a database. So basically, it's just a table within Lisp that's mapped to that VRF. So I can do this with the GRT, the global routing table. I can do it with another VN. So I can make a VN inside my fabric a shared service if I want to. The one thing I can't do is I can't make a VN that's also a subscriber, a provider, right? So I can be a provider or I can be a subscriber, but I can't be both. So if I wanted to access some kind of shared service, let's say within the IoT VN, from the campus VN, I wouldn't currently be able to do that. That's something we're looking at enabling in the future, but for the current version of SD-Access Extranet, we're not going to allow people to have subscriber to subscriber relationships yet. okay? So these are the most common use cases we see and that we expect to find within the customer base as they start to deploy this. So how does this work? Let's take a look at a packet walk. So let's say I have a fabric edge node here, two fabric edge nodes, and the IP addresses that you see associated with those currently are their loopback addresses, because in SD-Access, all of my routing and packet forwarding within the fabric is done from one loopback to the next. You'll see a loopback up on the border node. And then maybe I want to access this shared services device, this server 30.1.1.1 out in my data center. Now, traditionally, again, if I wanted to do that, if I had separate, for example, hosts here, one in the campus VN, one in the IoT VN. If this server one was in my global routing table, then somewhere I'm going to have to get that traffic from the campus VN and the IoT VN into the global routing table, and that's route leaking, and that's where we usually did it on those peers. But now what we can do is we can say, okay, if host one or host two wants to talk to server one, we don't have to do that external route leaking necessarily anymore. So what does this look like? So first, if we look at the IP to RLOC, and RLOC is routing locator, if you're familiar with Lisp, this is the same term that we use in SD-Access. We call it an edge node, but in RLOC and Lisp terminology, it was pretty much the devices where the clients or hosts themselves were attached. So the IP to RLOC table in this case shows host one with its IP of 10.1.1.1 is connected to 192.168.100.1. Host 2 is connected to 192.168.100.2. And the server is in the infra VN. Now, the infra VN in the SD-Access world is the global routing table, right? So if you've set up SD-Access before and you've done something like wireless or you've done something like extended nodes, you've had to put those management subnets for those devices into this, what we call infra VN. And when you do a layer 3 handoff from a border node to any peer device, usually you're going to hand off this infra VN, but that's just the global routing table, right? So we've always just called it the infra VN. So I've got these 3 separate spaces now set up in my table here. So I want to set up a policy that says I want the infra VN or global routing table to be my provider. I want the subscribers to be my campus VN and my IoT VN. Now, how does this work? Now, traditionally, let's say I have a host 1 to server 1 communication here. So I'm going from 10.1.1.1 to 30.1.1.1. My traffic would egress from my client device, hit the fabric edge node, and like with every other campus, SD-Access communication, the first thing I'm going to do is I'm going to query the control plane. It's going to ask the control plane, where is 30.1.1.1? Now, in a traditional SD-Access network, the control plane would say, well, in your VN, there's nothing, right? So I'm going to first look in the campus VN because that's where the request is coming from. So let's look in the campus VN and see if 30.1.1.1's there. Well, no, it's not. The only thing I have there, the only thing that's registered is host 1, which is 10.1.1.1. So I don't have a match. And traditionally what we would do in this case is the control plane node would send a message back to the fabric edge saying, hey, I don't have 30.1.1.1 in the campus VN, so go to the border node and let the border sort it out. And then I would go out my campus VN, and then I would do route leaking somewhere else, and then I would go off to the server. But now what we can do, because we've set up this policy that says that the infra VN is my publisher, or provider, sorry, and my campus VN is a subscriber, I can look in the infra VN. So once I see that there's no entry for 30.1.1.1 in the campus VN, I can now look in the infra VN. And I can say, oh, okay, well, I have this policy. I'll look in the infra VN, and sure enough, there is server 1, 30.1.1.1. It's located off the border because that's where I'm learning the route to that subnet is in the infra VN, probably from BGP or something northbound of the border. And so I will tell in my reply now to the fabric edge node, I'll tell it to go to the border. Now, this is a little bit different than it going to the border in the first case, right? Before I said if I don't find it in my VN, then I'm going to go to the border, but in the campus VN. Now I'm going to the border in the infra VN. So I've essentially hopped VNs within the fabric without having to go and use any kind of other route leaking mechanism external to the fabric. And so when I send my traffic from the fabric edge node to the border, I'm going to encapsulate it in my VXLAN header. So 192.168.100.1 is my source, 100.3 is my destination, and I'll have my original packet shown in dark gray there, host 1 to source 1. The border will strip that VXLAN header off. It will look at the original packet information now, and it will see that 30.1.1.1 is available in the infra VN, and I will just simply forward the traffic on to server number 1 from the infra VN. So no longer will I have to rely on an external device to do any kind of route leaking. I can do that within the fabric. And whether this provider VN is in the fabric or out of the fabric, it doesn't really matter. If server 1, let's say, had been in another VN inside the fabric, and I had just designated that VN as the provider, then I would have probably never gone to the border. If that server, let's say, was attached to another fabric edge node, I could have just gone through my fabric underlay infrastructure to that other fabric edge node and gotten to that server. So where these devices live from the provider perspective is kind of irrelevant. It's the fact that I can now do this lookup inside the fabric itself without having to use an external device, do any manual configurations, any kind of route leaking and things of that nature. Right? So this is what this changes a lot. From a design perspective, this becomes very interesting because now if I can take advantage of this, I don't need a peer device. I don't need a router, switch, firewall, or whatever to do my route leaking. The other thing is from a routing perspective, once I have done the relationship that says I'm going to have an infra VN as my, or / global routing table as my provider, and I'm going to have other VNs as my subscribers, I really no longer have to even do handoffs for the subscriber VNs, because what's happening now is I'm putting those subscriber VN subnets available to the infra VN, and if I advertise the infra VN to the outside world, 10.110.24, 20.110.24 will be available to be reached from the outside world just by advertising the infra VN off the border. So if a customer, for example, has 3, let's say this is not a data center cloud, let's say that's an MPLS cloud or something. Let's say I've got 3 VRFs through the MPLS cloud, or I was looking to get 3 VRFs through the MPLS cloud. I might not necessarily need that now because I can advertise all of my subnets within the fabric just across the global routing table or whatever other VN I want to make it. And if you want to make the global routing table a VN, which you can do obviously, then you can still share that as a provider network and advertise it in its own VN out to the outside world. Right, so but it's one thing to be careful of because again, once I do this relationship, I am going to advertise those subnets in the infra VN outside the fabric, right? So if a customer has specific, I want to map every VN in my fabric to a VN in my MPLS backbone or something like this, that won't happen anymore. So it's something to be wary of from a design perspective. Okay. So that is a single site kind of host to server or shared services. Now let's say I'm coming in the other direction. It's pretty much the same thing. Matter of fact, it's exactly the same thing. First, the traffic would come from server 1 and hit the border. The border would look in the, let's say I'm going to 10.1.1.1. The border would look in its own infra / GRT. It wouldn't see it, but it would see that I have a relationship between the infra VN and the campus VN. That would then prompt me to look in the campus VN IID space. And once again, IID, remember, is instance ID with Lisp. Once I found that, I would just forward it to the Fabric Edge node where that host was registered, right? So this works in both directions within the fabric, right? This does require that list pub sub capability that I mentioned. So this is, again, advertised as part of that information between the control planes and borders. So you do have to have the list pub sub within a site in order to take advantage of this. All right? So that's a single site. Now, if I have a multi-site design where I have what's called an IP transit, with SD-Access, we can have a couple of different transit types. One's called IP transit, and that's where I'm just handing off VRF light, usually via BGP, pretty straightforward. But I can also have something called an SD-Access transit. So an SD-Access transit is interesting for customers that might have geographically disparate sites, but they're connected with a network that can support an MTU large enough to carry the VXLAN header, because in that VXLAN header, I've also got my VN information and I've got my SGT information. So if I want to do macro and micro segmentation, I can do it natively within an SD-Access transit environment without losing that micro segmentation, right? In an IP transit, I might have to do something else like SXP, or maybe I can do IPsec, for example. IPsec can carry the SGTs, or DMVPN or something like that. Or if I'm going to a Cisco SD-WAN carrier, then that will also carry the SGTs. But for a customer that has the ability to natively carry the VXLAN header from site to site, then that's what we call an SD-Access transit. And it uses something you might see in the middle cloud there called a transit control plane, or a TC. And a transit control plane is a device that stores all of the subnet information for all of the sites. So site 1 on the left here is going to have different subnets from site 2. And so if a host in site 1 wants to talk to a host in site 2, the transit control plane will tell the border node how to get to the other site for that subnet, right? So that's what the transit control plane does. But when we start adding in things like this capability for SD-Access Extranet, the transit control plane also can advertise these policies between sites. So for example, let's say I have my kind of same setup that I had previously. We have that setup where, again, I've got but here I've just got the campus VN in site 1, the IoT VN in site 2. Again, I've got my infra VN here. To be fair, I would have an infra VN on the other site too. We just didn't show it in that box. So I've got my hosts registered, or at least I've got my local subnets registered in the VN there. But you know, when the host comes in, they'll register within each VN in each control plane. So, wow, this is this is long. So the transit control plane now, again, is going to take prefix registration information from each site. So you'll notice the purple prefix registration from site 1, the kind of orangish prefix registration from site 2. And that way, if the hosts want to talk, the transit control plane holds the knowledge of all of those sites. But what if I now have policies in the sites that say I want to leak, for example, or I want to have shared serve this extranet capability from my infra VN to just the campus VN in this site and just the IoT VN in that site. So up here in the upper right, you can see I've got my VN policy set up, same as I had previously, infra VN with my provider, campus and IoT VN with my subscribers. What's going to happen is on the left-hand side here, I've got my VN policy with my infra. On the right-hand side, I've got my VN policy with my infra. Now we show the control planes and borders separate here on the slide, primarily for educational purposes. And the vast majority of deployments that I've seen in my time doing SD-Access, which has been, I don't know, several hundreds, the vast majority will have the border nodes and control planes co-located. And in that case, we still do set up a pub sub session between the control plane and the border internally between the two separate processes. So I'm still having a communication here. So I'll have a provider VN configured on the border side, and on the control plane side, the control plane process side of that, I would have my policy set up for this extranet capability. You can also see here on the transit control plane that I have this visibility now for this policy from both sides. So if I just had the campus VN set up on the left and the IoT VN set up on the right, and I was just doing the policy locally there, the transit control plane has now the view of all the policies from all the sites. Now, obviously, if 30.1.1.1 is over here in the data center and the IoT needs to access that for some reason, I have to have knowledge of that on the site number 1 as well, because I'm going to hit that border node as well, right? So what we're going to do is, again, this is where this publish, remember I mentioned publisher subscriber architecture. This is where that list pub sub capability comes into play. So now I gather the information from the sites, and then I publish that information from the transit control plane to the border nodes of each of the sites so that they have the visibility if traffic now comes in from either one of those VNs. And I publish the policy information so that, oh, sorry, then I also register with the control plane. I'm so used to them being co-located that I always forget that part. But yes, we will register them with the control plane as well. But now I'll have full policy visibility on both sides, right? So the transit control plane is not only taking in my subnets and providing me with connectivity for those subnets across the entire SD-Access transit environment, it's also looking at the policies and making sure that I have those policies communicated to each site so I know where to go for each one. Okay? All right.
Actually, can I ask a question?
Absolutely.
So all of the policies that you're writing here, I'll call them tags essentially, right? Like infra, campus.
Well, these are
those one-to-one relationships?
So these are the virtual networks, so that whatever name you give them, right? Are they one-to-one? Well, in this case, I can have the provider subnet, the provider VN can have multiple subscribers. So I guess you could say that's a one-to-many. But the subscribers don't talk amongst themselves in a subscriber-to-subscriber relationship. So I don't know if I'm understanding what you mean by one-to-one, but the publisher or the providers can have multiple subscribers.
So campus, right?
Right.
Like, is that limited to a single subnet?
Oh, no. Okay, I got you. No, you could have, that's an entire virtual network. So you could have, yeah, we showed one subnet. You could have as many subnets as we can support in a site inside of one VN if you want to. So this could be 20 subnets, and the entire VN would now have access to the infra VN. So all the subnets in there would be part of that relationship. So when I'm advertising my infra VN outside the site, all those 20 subnets would get advertised as part of that as well.
Now, if that was spread across multiple sites.
Let's say I had campus over here that was 10.1.2.0. That would still be part of that relationship.
Okay.
Yes.
Now, is there a way to reference that in the policy by site, comma,
subnet and stuff? That I'd have to check on some of those details to see how that's referenced in that case. I know that we don't do, for example, let's say I had 10 subnets in the VN. I can't say I only want the policy for these 5, right? It's an all or nothing right now. You either have a relationship between VNs or you don't. So you can't say that it's some subnets and not other subnets. Now, of course, you could then filter that somewhere outside the fabric if you wanted to, and then you could still hand off this VN and another handoff if you wanted to. But we don't have that in this version. We don't have that granularity yet.
Okay, thank you.
Sure thing. Okay. All right. Anything else before I move on? Okay. So that's pretty much it on the SD-Access extranet capability. So we've seen some of the benefits here. It is fully automated, so that's, we're trying to do as much of that as possible with SD-Access. Everything from a border down to an edge node is automated, and this is part of that. So it is fully automated for support of V4 and V6. The asterisk you see up there is actually the point we just talked about. I can't have 10 subnets in a VN and only have this policy for 5 of them, right? So that's what that means by no subnet filtering.
Okay.
Basically means it's the whole VN or nothing. avoids hairpinning. So if you remember the first picture I showed you, if I wanted to go from green VN to red VN, I actually went out, hit the peer device, and then I hopped over via VRF route leaking and then came back down. So this could avoid hairpinning. If for example, my two VNs that are publisher and subscriber are within the site and aren't even leaving the fabric, if it's like a server hanging off an edge node, I'll just go across my underlay. I'll never even touch the border. So I don't have any hairpinning with that. We talked about the TCAM blow up. Again, if I do any kind of route leaking, usually I now have to take all the forwarding entries from that one and put it in the other one and vice versa. And I start to get TCAM elevated entry numbers, if you want to call it that. This removes that because this is now done inside of Lisp, inside of the control plane itself. So I'm not impacting any kind of TCAM scale by enabling this. Might not have a need for a peer device. So this one, have to be careful. A lot of people, when they first see this, they go, awesome, I can get rid of the fusion or the router and this and that. Maybe, not always. It really depends on the use case. You have to be careful with that. Again, if your organization is set up such that you've got VNs already established across an MPLS backbone and you want to do a one-for-one mapping, it might be better just to keep that and go do your route leaking somewhere else on a firewall or something else that's already set up to do that. So this isn't a cure-all for all shared services necessarily, or for all use cases where you've got that peer device. And then avoid route leaking on every border as well. And then finally, I just wanted to go through again and reiterate what the requirements for this are. So in terms of SD-Access code, it's going to be 2.3.4. That is not generally available yet, but we're expecting it probably mid of October or so. iOS XE 17.9 is the iOS version that's kind of tied to that DNA Center release. So as long as you've got these two things, it does say July, August, but we're a little off on that.
We're optimistic.
We're a little bit. But 17.9, as long as you've got that as well with that, then this is where that's supported.
Could you briefly give one or two examples of the verticals that use this in their use case to put a practical edge on it?
Yeah, so verticals themselves, I mean, it's really going to be anywhere where you might have, and where I've seen it pop up and people want to use this a lot, is where they might have branch environments, or they might not control the CPE device that they're connected to so much, right? So if I can just stick everything in a global routing table right off of my Fabric Edge node and not have to ask my provider to do route leaking somewhere, or have to converge my VNs, VRFs into a single VRF because I only have one VRF across my WAN. This is where I see a lot of interest for that, so that I can cut down on both the number of devices that I have to purchase and or rely on my service provider to have to do things for me on their equipment, which they might not want to, or it's going to cost me money. So I don't think this applies to a specific vertical. I think it really applies to specific use cases of how the network is deployed more than anything, which can pop up in almost any vertical, to be fair. I've seen people interested in this across, healthcare with remote clinics, universities with remote campuses, things like this, banks with lots of branches. Well, I work on those a lot, so those three that pop up. But anything that's kind of like that, I would say.
Okay. When you're interfacing with those teams, how often are they multidisciplinary networking groups, and how often are they dedicated to access layer connectivity?
It really depends on the size of the organization. I mean, if you go into a university, usually it's a 2, 3, 4 person team. They're kind of doing it all. You go into some of these large multinationals, they have a WAN team, they have a LAN team, they got a wireless team, they got a security team. It really just depends on the size of the organization more than anything. And yeah, getting those folks to work together and talk sometimes. And this actually might help with that, because now, hey, if you're the WAN team, I'm just giving you a global routing table. There you go. Have a nice day, right? I don't know if that's where you were going with that, but
it is and it isn't. The thing that I always struggle with SD-Access, and this is just across the board, is that if I'm an access team, a routing team, a wireless team, a security team, and a data center team all in one, I don't know how I take that technology on. But when I say that to Cisco, they make it seem like, oh, it's magic fairy dust and it just works.
Exactly.
But of course.
But I have a hard time getting like the smaller multidisciplinary teams.
Right.
Like maybe they can put it in and they can put it in a basic mode.
Right.
But when we start getting into the depth here that like we're talking
Right.
about now, it's hard for those teams.
I can appreciate that because I used to be on one of those teams before I joined Cisco. And I can appreciate that this, this can seem daunting to some people, especially you've been doing things with layer 2 access, layer 3 distribution for the last 20 years. Now we're saying do layer 3 access with this, that, and the other thing. To me, it's just a matter of, it's on us to make sure that our partners, customers, anybody that's interested is enabled, and we have the right information out there for them that can make them feel comfortable enough to do it. That's about the best answer I can give to that. But I totally understand your point. I mean, before Cisco, I worked for a company and I was the server guy and the router guy and the phone guy. We didn't have wireless then. I was the wireless guy, security guy. I was that.
You're dating
So
yourself.
yeah, I do. So I can totally appreciate that question. But the best I can say is we just need to make sure people have the information at their fingertips, that they're enabled, our partners enabled, et cetera.
But that's also probably true in general of segmentation with any technology, because as soon as
Yes.
you say I'm going to segment,
And
it
that's
gets complicated.
the challenge I find is customers that never had to deal with VRFs, especially in a campus. Now looking at this and saying, yes, this solves some of my use cases because I want to do, guest separate and corporate net rate, and I want to bring in IoT devices and keep them segmented. And so this is appealing for the business problems that SDA can solve. But then you start saying, oh, well, now I got VRFs down to here and I've got, how do I do VRF? I've never done VRFs before. I just hand off a global routing table and that's the way it works. So yeah, that's been a lot of the challenge as well.